Alright, so we're going to look at how electrochem and equilibrium are affected. So we looked at with Gibbs free energy delta G is equal to that negative NF of E of the cell. So that was under like standard conditions. There's another form of delta G that we've already looked at with equilibrium in K, where negative RT, negative R times T times the ln of K equals delta G. So we can have those set to be equal to one another. And then looking at how it rearranges to solve for like the E, the energy, if we change different conditions. It'll rearrange to where the E is RT over NF times ln of K. And that can also be derived from this equation because R is a constant. Remember, the not symbol means it's the 25 degrees Celsius. And then F is a constant. So they simplified it to be this 0.0257 over N moles of electrons times ln of K equals E. And it can also be derived from this one with log of K instead of ln of K. This one is not explicitly on the reference sheet because what is on the reference sheet deals with what changes if we change the equilibrium position. So the one on the reference sheet deals with Q instead of K. So, like I said, the E naught of the cell assumes standard conditions, which means things are going to typically be 1 molar at the 25 degrees Celsius. But we have to look at what happens if the solution is not 1 molar. How is that going to affect that E value? So we're going to look at this equation. And this is that Daniel cell where we have like zinc and copper as our anode and cathode. And the E of the cell is 1.10 volts. And we would have to look and see what happens if we change the molarities from 1 molar, whether we increase it, decrease it, things like that. So let's look at, or what we're going to look at, and I'm going to show you the equation in a minute, is we're going to look at what happens if we increase the copper 2 concentration to 2 molar instead of 1 molar. We're also, so if we increase copper 2, that's increase in the reactant, which way would equilibrium shift? If we're increasing the reactants, remember it shifts to the opposite side. So it would shift towards the product side. So if that occurs, what happens to like our K or our Q value? If there's more products, K or Q would get bigger, which means the cell voltage would increase because we're increasing K or Q. When we plug that in, it's going to increase our E of the cell. So anything that is going to increase your products would increase the E of the cell. If it is going to increase our reactants, it decreases K or Q, our E of the cell would decrease. Just right. Just right.
So if we increase the products, the reaction increase,
Yes, hang on, I'm going to do that one in a second.
Okay.
Yeah, but like I said, if you increase the reactant, it shifts towards the products, which is going to produce more electricity. On the flip side, what happens if we increase the zinc concentration to 2 molar? We're increasing, or excuse me, sorry, it didn't draw it. It would increase on the product side, which would shift equilibrium which direction? Shift it to the left, meaning we have more reactants, so K or Q would go down, so the E of the cell would go down. And then same kind of thing with the last question. What would happen to E of the cell if we're using only a 0.01 molar solution of zinc? Okay, let me erase my little notes so we can kind of talk through it. So if we decrease the concentration of zinc, which way is equilibrium going to shift? Towards the product side. So we would make more products. What would happen to Q or K? It would go up, meaning that our E of the cell would go, if K or Q goes up, E of the cell goes up. Yeah, if we increase the products, we're going to increase Q or K and increase E. Okay. So that's kind of conceptually what happens. We're looking at that equilibrium shift with like Le Chatelier's principle and stuff. We could actually calculate what the E of the cell would be. This is a formula that is on your reference sheet. I don't know that they would actually have you calculate it. I've never seen them have you calculate it in the past. It's been more of like conceptual. Okay. Oh, sorry. There were arrows there. Alright. So, one thing that they derive, and this is not explicitly on your reference sheet, there's another form of it. But we talked about how you can get like delta G and delta G naught from different situations. This, we could substitute in delta G for the negative NF of E to get this formula that is on your reference sheet. This is our Nernst equation. So we could use this equation to figure out what the new E would be if we know the E of the cell. Remember, R is a constant, T is the temperature, N is the moles of electrons, F is Faraday's constant, and then we have the natural log of Q. So if we know those changes, we could figure out what the new E value of the cell would be under those non-standard conditions. And this is that last equation under thermodynamics and electrochem. And here's the simplified version where they already plugged in like R, T, and F, which is the Nernst equation. They have this middle one on your reference sheet though. That's what's on your reference sheet. Alright, so I will tell you though, calculations using this, I've never seen tested. It's only been conceptual. Even though this is a formula on your reference sheet, I think it's there to help you with the conceptual piece. But I've never actually seen a problem where they have to plug it in and solve. So, but in order to be like an increase in moles, it would have to be a different reaction because it's like the moles of electrons that cancel out. So like, even if you increase the amount, those moles of electrons are still the same balance-wise, canceling out. And part of it is like, even if you included more moles of like solid zinc, remember solids don't show up in K or Q. So it's really only the ions that are affecting K or Q. Alright, and we already talked through this. This is that same slide. But looking at if we had copper, if we increase copper, we said it shifts to the right, so E would increase. We could actually plug in those values. And remember, like Q would be like 1/2. So plugging that in here, that's what causes it to increase. Same kind of deal with the zinc. We said if we increase zinc, it shifts to the left, which we said would decrease Q or K, meaning that E of the cell would decrease. Same kind of deal happens. If they were actually to plug it in, Q would now be, it'd be the natural log of 2, which would make it a smaller value that they're dealing with. And then same thing we talked about with if we decreased zinc's concentration, we said it shifts to the right. So there's more products. So what would happen to Q or K? Increase. So E of the cell would increase. Same kind of deal. If they actually like plugged in the values, it's going to be that like little baby decimal number.